So now you can see that there's a blue lights at this button, indicate that now this main sample compartment is activated. Alright, we can use this compartment to measure samples now. But if let's say we want to use the built-in ATR instead, so again, just by a touch of a button, the system will actually change the IR path light, and now you can see that the blue light switched from the main sample compartment to the ATR compartment, which means that now the ATR compartment is activated for measurements. So these ATR compartments have its own detector, and it can cover mid and far region measurement. So how do we actually change the beam splitter from KBR to solid substrate? Because KBR are mainly for the mid-infrared measurement, but if let's say we want to venture into the far infrared, we have to change the beam splitter to solid substrate in order to perform the far infrared measurement. And these changes I will show you on the software itself. The indicator for your desiccants. So this is the indicator for your system. It will be located at a different position, but it will still looks the same. So this indicator, supposedly it needs to be blue in color. Alright, this color is already a little bit faded. It should be darker in color, maybe something like this. Alright, maybe lighter than this, but definitely darker than this color. So you have to ensure that this indicator always is in blue in color. Alright, if let's say it turns to white, then means that you have to remove the desiccant to regenerate it already, because when it turns to white means that your system internal have moisture, which it will actually attacks those optics. So always ensure that your desiccant is in blue in color. For your is50 system, the desiccant is located at this position. This is a close-up picture. Do always monitor your desiccant indicator. Make sure it's blue in color. If let's say this blue color turns to light blue or turns to white, means that your system internal have a high humidity. And although over here stated change desiccant when the indicator turns pink, but I will recommend don't wait until it turns pink. If let's say it turns light blue, pale blue, or even white, then you have to change the desiccant already. So how do we remove the desiccant? This how do you say, the opening over here. So to unlock, you just need to turn this knob to the left hand side, and then you just pull out the cover, and inside you will actually have 4 desiccant pack inside this the cover. But if let's say you have no extra packs of desiccant, you can actually take these 4 packs. Make sure you remove this cover, because this cover can't enter the oven, it will actually melt. So these 4 packs you can actually place into a clean oven and heat up to perhaps about 90 to 100 degrees C for 5 to 6 hours. Then you remove the desiccant and place it inside a desiccator or dry box to cool it down first, because if let's say it's hot, you cannot put it back into the system. So you have to wait it to cool it down first inside a desiccator or a dry box. Then only when it reaches back room temperature, you slot back this 4 desiccant into its cover, and then place it back into the system. But usually after regenerate the desiccant, it will not last long. So it's good to get from the service engineer quotation for a replacement pack. In case even you have reheat the desiccant and replace it back into the system, if let's say this indicator still doesn't turn back to this blue color, then you will need to purge your instrument, because this indicates that the system internal have a high humidity. Therefore, we recommend you to purge the instrument. Usually, if let's say you purge about 15 minutes to half an hour, this indicator will turns back to blue in color. Okay, so do always monitor your indicator and make sure it's blue in color, or else if you do not monitor it, it turns white or it turns pink, the moisture in the system will start to attack all those optics in the system. So this will actually cause the system signal failure. This is the Omnic software layout. As you can see from here, the experiment now is data transmission. So at the system now, the main compartment is actually activated. So if let's say I switch to the ATR compartment using the touch button now, the software will automatically change the experiment setup as well. So after the optical change within the system, the software also will do a system check to see whether is the signal okay or not. So now it's already reached the ATR compartment. So now the built-in ATR compartment is activated for measurements. When we want to do experiment setup, over here we have the icons for experiment setup. The bench part is more on the measurement settings like number of scans, resolution, how do we want to collect the background. Now under the bench tab, what we have over here is the system hardware settings, and here is the system signal. So first of all, the sample compartment, we have the choice of the main compartment or the built-in ATR. So we can change from the main compartment to the ATR compartment either from this software or from the touch button that I have shown previously. The detector will be automatically detected depending on whether you are choosing the main sample compartment or the built-in ATR. Beam splitter, at the moment, the system that is connected to this software have two beam splitter in the system. The KBR for the mid-infrared region and solid substrate for the far infrared region. At the moment, we are using the KBR beam splitter, hence the minimum and maximum range is preset 4000 to 400 wave number. When we change to the solid substrate, the minimum and maximum range will change accordingly as well. So now I'm going to select the solid substrate beam splitter. What you will notice is that over here, the signal is already gone. The reason why is because now the ABX, the automatic beam splitter exchanger, is changing the beam splitter automatically. And what you can see over here is also when we choose the solid substrate, the maximum and minimum range also change automatically. We will just need to wait a little while, less than a minute, or maybe about 30 seconds. Wait until the signal comes back. So now we see this signal, so means that the switching of beam splitter is completed. Then we can start on our sample measurement. So this is the Omnic software. On the desktop, you will see this logo, and then it's written there Omnic. So this Omnic software is used for the sample measurement and then also on the spectrum analysis. So you just need to double click on the icon and then it will open up this software. So the first thing to monitor is the system status. So for your case, your system status should be green in color. As long as the system status is green, means that you can start to perform the measurement. Your system is in good condition. But because mine is a simulation software, so mine is having a red cross. So generally, if let's say your system status turns red, it could be due to a different reason. First, perhaps the software means that the PC and the system is not connected. So if let's say this is the case, you just need to check on the USB between your FTIR system and the CPU. Okay. Beside of that, Also, they will monitor the schedule for the preventive maintenance, which is actually done 1 year once. So if let's say already approaching the expiry date of the preventive maintenance, then it will actually turns yellow to indicate you that it's going to expire. If let's say it turns red, means that the scheduled maintenance 1 year already passed. So you can arrange for our service engineer to be on site to perform the preventive maintenance for the system. Alright. Okay, and then the next thing over here is the experiment. So it's stated is50 main sample. So this main sample is referring to the main sample compartment, because for your system, you have two sample compartments. One is the main sample compartment, and then the other one is the built-in ATR. So this main sample compartment is for the transmission technique. So in order to perform this transmission technique measurement, you will need to do some sample preparation. For example, if let's say you have liquid sample, you will need to have a liquid cell. You inject the liquid sample into the liquid cell, then you place in the main sample compartment to do the transmission analysis. If let's say you have powder sample, then you will need to mix with the KBR powder and then press into a pellet. Then only you slot in for the transmission technique. Alright, so that is the main sample compartment. So if let's say you want to measure your sample using the built-in ATR, so on the hardware, you just need to click the button beside the built-in ATR, which is shown earlier in this video. So you just click on it, and then the light will turn to blue light. So as long as the blue light is at the built-in ATR compartment, means that the ATR is ready for use. So as you click on the hardware, over here the experiment setup also will change accordingly. Alright, so because my one is a simulation software, so I can't change to the ATR at the moment because it's not connected to the system. So you will just need to make sure that you click on the hardware first. Okay, so make sure that over here is the is50 ATR, then it's good enough. Okay, then once you have clicked on the hardware, so before we start sample measurement, we will look into the experiment setup. Okay, so experiment setup, the first tab under collect, what we should look at is first of all the number of scan, which means how many times you want to scan your sample. So generally, I would say 16 scan will be sufficient. Means that we are going to scan your sample 16 times and they give you the average. So the more number of scan, you will actually get a better baseline, less noise. So 16 I would say is usually sufficient. If let's say 16 you still see the baseline is quite noisy, then you can actually increase it to 32 times. Okay. And then for resolution, you also can change different resolution, but for solid and liquid sample, I would say resolution 4 is sufficient. Okay, if you choose because the resolution, right, the smaller the number, the better the resolution. Okay, but you doesn't need to go for such good resolution, let's say like 1 or 0.5. If you use too good of a resolution, your sample spectrum actually will be very noisy because they collect too much of data point. Okay, so 4 will be sufficient if you are dealing with solid or liquid. Only if you are measuring gas sample, then you might need a better resolution of 1 or 0.5. Then comes to final format, which is the y-axis, because the x-axis will be the wave number, it will be fixed. So for the y-axis, you can choose either to look at percentage transmittance or absorbance, depending on your preference. Anyhow, this can still be changed after you collect a sample spectrum. Alright, then correction, I will just put none so that we get original data without any corrections, because all these kind of corrections we can still perform after we collect the spectrum. Last but not least will be the background handling. So for me, I would recommend to use the first one, which means that collect a background before every sample. So which means that every time when you want to run a sample, you will need to collect a background first, then only a sample. Because environment does affect on the sample spectrum. If let's say your environment is very fluctuating, then if let's say you do not collect a new background every time, you use back some old background, your sample spectrum might have moisture, noise, CO2 peak, okay, all this kind of interference. So for me, I will recommend the first one. So that's it for the collect tab. And then the next one is the bench. So this bench is actually looking into the system hardware. So for your case over here, you should have a red signal because mine is simulation mode, so there is no signal over there, so it doesn't matter. Alright, so comes to sample compartment, it will be either the main or the main means the main sample compartment, the transmission compartment. So if let's say on the hardware you already choose the built-in ATR, so over here it was stated the is50 ATR or stated built-in ATR. So the detector, you doesn't need to change, it will be automatically changed according to your sample compartment. Alright, so the detector, you doesn't need to worry about it. So for your system, have two built-in beam splitter. One is KBR, one is solid substrate. If you want to measure mid-IR spectrum, which means the wave number from 4000 to 400, then you choose the KBR. And then so the transmission compartment and the built-in ATR, both of it, you can collect the mid-IR region, which is using the KBR. So if let's say you want to measure the far IR region, which means from 1008 down to about 50 wave number. So from this beam splitter, you have to change over here. So you just click on this drop box, then you just choose the solid substrate. Then when you click on it, then you will see that the signal will disappear because they are changing the optic, and then once the signal reappear means that it's done. So the solid substrate beam splitter for the far IR is only dedicated for the built-in ATR technique. So the transmission compartment, you can't measure the far IR, only the built-in ATR can measure the far IR. So the recommended range also, you doesn't need to worry. If you choose KBR, then it will be default 4000 to 400. If you choose the solid substrate, then it will change accordingly, 1800 to about 50 wave number. Alright, so that's how you change whether you want to measure mid-IR or far IR for the built-in ATR. And another point is that if you want to measure the far IR region using the solid substrate, you will need to purge your FTIR with nitrogen gas purging. So I recommend purging at the pressure of 20 psi. Okay, 20 psi, and then purge maybe perhaps about 10 to 15 minutes before you start the measurement. Then continue to purge during measurement. Once done measurement, then you can just stop the purging. So why do you need to use nitrogen purging when measuring far IR spectrum using the solid substrate? Is because the far IR region, the lower wave number region, is very sensitive to environment moisture. So this is the reason why purging is required, or else your spectrum will be too much of the moisture noise interference. Okay, but mid-IR with the KBR doesn't need any purging, just the far IR part. And then comes to here, the gain, I would recommend you to go for auto gain. Then you can just choose auto gain over that. So after all this kind of setup, actually behind all this tab, you doesn't really need to worry about it. If let's say over here is tick, you can just untick this quality check. Alright, just untick it. Then over here, all this can just remain default. Diagnostic is they will actually monitor the system hardware, so like the laser, IR, and detector, and so on. So if let's say there's any hardware malfunction, then you will see the red cross over here. So again, because mine was not connected to a system, so everything is just crossed out. And then last but not least, the configure nothing much here also, like everything can just leave it default. So I would say the most important will be the first collect tab and then the bench over here. Alright, so perhaps you can go for the KBR bin splitter, and then if let's say all this kind of setting is what you frequently use, you can then click on save as, and then you just click set as default. Then you just go for save, then want to replace, then you just click yes. So by saving these things, so which means that every time when I launch the software, right, all these kind of parameter will remain. So you doesn't need to always come here and change to the parameter that you want. Okay, so you can just go for save as and just make sure that you click on the set as default. All right. Okay, so we are done with this. All right, so because we have tell them that I want to have a background before every sample, right? So whatever changes that you do, just make sure you click on OK. Then it will be set to that parameter. So now we can click on the collect sample and then place in our sample name. For example, let's say A. Okay, and then they will prompt you to prepare to collect the background, because in the experiment setup just now we have tell them that we want a new background every time before we measure a sample. So therefore, even when we click on the collect sample, they will prompt for the background. So before you click on this OK, make sure that you clean the FTIR crystal. So let me show you the close-up of the crystal. So this is just a stainless steel base plate. So the crystal is actually the middle part. Okay, so the middle one, about 3 mm in diameter, that is the crystal. So sample doesn't need to be much, as long as it's cover this crystal area, then will be sufficient. Before measuring sample, when we want to measure a background, so we have to ensure that the FTIR crystal is clean before we measure the background. So I have some solvent over here. You can use ethanol, IPA, or even acetone is okay. So we will just need to put some solvent on a tissue and then just rub the crystal, just clean it. Alright, with some force, so that if let's say there's any contamination, the contamination will be cleaned out. Alright, so besides cleaning that crystal, and after cleaning, you also need to ensure that the solvent is fully evaporate before you start measuring the background. Then beside the crystal, we will also need to clean the tip, because we will actually use this tip to clamp on our sample. So you also need to clean the top over here. Alright, when it's clean, then we can start to measure the background. So during background measurement, it doesn't matter whether this tip is at the side or on top of the crystal, it doesn't matter, as long as the tip is not touching the crystal, then that will be the background. So let's say now the crystal is already clean and solvent already fully evaporated, then now we can click on the OK. So now they will actually collect the background, the 16 scan. Alright, so once the 16 scan for the background is completed, now only we place on the sample for the measurement. Okay, before that, just to show you, behind here my spectrum is all the noise, because again this software is not connected to a system, so therefore your background will look different from this. Your background generally is going to be it's like a hill going upwards and then coming back down, so that is the proper background. And also during the background measurement or during sample measurement, you just need to monitor this bottom, the collect status. So the collect status should remain green during the background and sample collection. Alright, so now the background is done, we can then place our sample on the FTIR crystal. So once we are done with the background measurement, we are going to place a sample. So for example, over here we have some of the resins palette. Okay, so sample doesn't need to be much. Just enough to cover the 3mm crystal will be sufficient. Alright, so this whole thing, this stainless steel is not the crystal, just the middle part, the 3mm diameter. So sample enough to cover that 3mm, then will be sufficient. Alright. Before that, the cleaning solvent, right? So actually acetone is also possible, but acetone is much more stronger. Therefore, upon usage, right, maybe after half year or 1 year, the coating on this black coating might fade if you use acetone. Alright, but of course the crystal will not have any issue. Okay, so then now I'll place, after a background measurement, now I'm going to place a piece of sample. Alright, so this is a polymer palette. So because the size is actually quite large, so one palette will be sufficient because the one palette already cover the 3mm diameter of the crystal. So in order to have a good spectrum, a good contact between your sample and crystal is very important. So therefore, for solid sample, powder, film, that kind of solids material, then you will actually need to use the pressure towel over here. So you just push it to the middle until it clicks. Alright, and then you turn this knob until you feel the click. Okay, so I'm not sure whether you can hear the click here or not, but you will feel it. Alright, so one click will be actually sufficient because this is actually a calibrated pressure tower. No matter how many times you click, the pressure will be consistent. So actually one click will be sufficient. Okay, so after one click, and then we can start on the sample measurement. So once you have placed the sample with the pressure tower, then we can click on this OK. And then they will start on the 16 scan for the sample measurement. Alright, so once the sample measurement is done, then they will tell you that the data collection has stopped. Alright, this one, the quality error, you can just ignore it. For your case, it will not have this issue. Then add to window 1, you just click yes. So after measurement, we can remove the pressure tower. Okay, and then clean up your samples. Again, use some solvent and clean the crystal. Same goes to the top, the tip of the pressure towel. You can also actually measure liquid sample using this FTIR accessory. So after a background with the clean crystal, and now if you want to place some liquid sample, you just use some droppers, maybe drop 1 to 2 drop on the crystal, then will be sufficient. You can start the measurement. Okay, but if let's say your liquid sample are volatile, then just make sure that during the measurement, which is let's say a 16 scan will take about 30 seconds, right? Just ensure that during the 30 seconds your sample did not evaporate off. So if let's say your sample is very volatile, very easily evaporated, so during the 30 seconds of measurement, if you see your sample is drying off, you can just continue put a few more drops. So to make sure that the 30 seconds of sample measurement, your sample did not dry off, then it's okay. Then after okay, before that, so for liquid samples, right, you doesn't need to use a pressure tower. So liquid samples, cream or gel, those that are more liquid based, right, you doesn't need to use a pressure tower because liquid sample, when you drop on it, it will eventually have a good contact with the crystal. So only solid samples, powder samples, film samples, or you say like, for example, rubber glove samples, those are the material that you have to use the pressure tower. Alright, so after measurement, you can just clean the crystal with solvent again. Okay,